Hi everyone, welcome to our event. This event is brought to you by Data Talks Club, which is a community of people who love data. We have weekly events. This event is one of such events. If you want to find out more about the events we have, go to the description. There is a link to the events webpage on our website. You can check it out. We have a lot of interesting events lined up. And if something is interesting for you, do sign up. Then if you haven't subscribed to our YouTube channel for whatever reason, it's time to change it now. Go below the video, find this red button and click on that, and you will get all our videos in your feed. And then finally join our amazing Slack, where you can talk to other data enthusiasts. During today's presentation, you can ask any question you want. There is a pinned link in the live chat, so I'll go there, ask your question there, and I will be covering these questions at the end. And by the way, do you prefer questions at the end, or I can also interrupt you throughout the presentation?
Feel free to interrupt.
Okay, I will interrupt you. If something is relevant that I see in the questions, I will interrupt you and ask. Okay, with that, let me stop sharing my screen. The floor is yours.
Awesome. So hi, folks. Thanks so much for having me. I'm really excited to chat about all things data, and specifically today about analytics use cases in non-automated operations. And I'll give a bit of context as to why I chose this particular topic. But I think there's a real opportunity for evolving how we use data and AI, where perhaps we're not working in a digital company. So a bit of a background on myself. So I have about 10 years of experience working in analytics and operations consulting and strategy across a number of industries, notably in banking here in Canada, also more recently at HelloFresh. I'm currently the Associate Director of Data at HelloFresh Canada. And outside of work, I'm also a data science and machine learning instructor at a couple of universities here in Toronto, the University of Toronto and University of Waterloo, which is about an hour away from the city. So a little bit of context on my current role at HelloFresh. So I lead a team of data engineers, data scientists, and BI and automation specialists, and we support our entire HelloFresh Canada business. And if you're not familiar with HelloFresh, HelloFresh is a meal kit company. We essentially produce meal kits. So we have a manufacturing environment where we create meal kits. We procure groceries from different suppliers, different farms. We design menus. We put all of the relevant ingredients in a meal kit. And then we put a customer's selected meal kits in a box and deliver those boxes to their home. And so it's a highly customized, highly personalized product that, in addition to being a digital platform that people can engage with through our app, it also has a very big physical product production. And so it's a really interesting business to work in, especially for my team, because this means that we get to employ analytics and data science and automation solutions and machine learning solutions through every part of the business cycle. So everything from product design and product analysis all the way through manufacturing optimization, and a whole lot of different things around kind of the physical capacity as well. And for context on HelloFresh, so HelloFresh operates in 17 different countries. We are based out of Berlin, that's our main office, but we have operations here in Canada, in the US, and also in a bunch of other countries like Italy, Spain, Ireland, France. Ireland, I believe, is launching this year, and Spain is launching this year, but France came last year, Italy came last year, also Luxembourg, the UK, and so all over the world, really, and on very far east, we operate in Australia and New Zealand as well. Okay. So the topics that I want to talk about today are kind of the differences in, and I'm going to speak sort of about the full data life cycle, which starts at data collection all the way through using data. And the reason I want to talk about this is because the challenges that companies face, and now having the privilege to work at a company that has both a digital and a physical product arm, has really brought to light some of the challenges that physical product arms face that digital products don't have. And I think we live in a world now where we're so used to working with apps, we're so used to looking at these big tech companies that are entirely digitally focused, and they really have capacity to expand and capacity to apply various models and solutions, and really use their data very well to learn a lot about their customers. But you don't necessarily have that same capacity in a physical environment. So my goal is to speak a little bit about that, about the two different environments and how they differ. And then secondly, I want to talk about experimentation as a means of data collection for longer term applications. So I know experimentation is popular in some industries, and I know many companies are thinking about how do we build a culture of experimentation and how do we dedicate time and resources. So I'll touch a bit on that and some of the things we've done. I want to also highlight the importance of data management and governance, which is really critical for collecting good data. And then finally, we'll talk a little bit about analytics use cases in non-digital environments. So some of the ways that analytics can be used for production, for manufacturing, in environments that have a physical component. So to start off, speaking kind of broadly about the challenges between digital and non-digital. So digital companies like social media companies like Facebook and Instagram and all of those folks, they kind of have 2 points of data collection. So one is the data that users provide to these companies. Let's say you sign up for a Facebook account, you enter some information about yourself that's demographic in nature. And then they have a whole bunch of data that they collect automatically about you. So for example, your engagement, how long you look at different posts, which posts you like, what you don't like, who you follow. And the benefit of creating automatic data, so automatically creating data, the benefit of that is that there's no data issues, or very rarely are there any data issues. And so essentially these companies have huge databases of engagement event level data. And by event level, I mean data that is timestamped. So every single second of the day, a data point is captured about people. And so they have billions and billions and trillions probably data points about their people, which makes it really easy to build sophisticated models. Not that building models is easy, but when you don't have to worry about the quality of the data, it makes it really easy to build sophisticated models that can do a whole bunch of things. And so companies like Facebook, they don't even need to rely on the accuracy of the data you provide yourself. They can effectively look at all the data they automatically generate for you and understand your entire life. So everything around where you live, who you're friends with, what you like, what you don't like, and it's creepy, right? It's bordering a little bit on that line of being somewhat creepy, but this is how they do it. Now, non-digital companies, so companies that have a physical product, and I know manufacturing is one example, but even companies like grocery stores, right? If you think about going to the grocery store, you're more or less anonymous. And maybe you have a points app, maybe you scan your points when you leave the grocery store, and that provides the grocery store with some information about what you've purchased. But in a physical environment, you're pretty well anonymous. If you don't have a points app, you kind of walk in, you pick what you want to buy, and then you leave. And so for companies like grocery stores and clothing stores and anything with physical capacity that has a physical store that you're walking into, they can't really collect much data about you, and they don't have that benefit of automatically creating data. So they really can't get to know you that well. And so when they're trying to decide, how should we design a product that's going to be beneficial? How can we design a personalized product? It's really not that simple for them because they just don't know you that well. And so a lot of companies with a physical presence have made efforts to do this. So either they will, get you to sign up for an email list, or they try to get you to purchase something online, or, they try to get you to sign up for their points program. And that's really the intent of those programs. But again, that leaves a very kind of limited view of the information that they have about you. Now, data that is collected. So let's say, for example, companies try to implement some sort of data collection mechanism where they say, for every customer that comes through the store today, record something about them. So based on your observations, and as an associate, maybe you want to record something about them. Or in manufacturing, for example, where let's say a lot of manufacturing that isn't automated, like a lot of food manufacturing locations, like in HelloFresh is an example of this, Amazon's another example of this. Anything that's like a pick and pack operation is really difficult to automate because different boxes, let's say Amazon, when they ship things out, every single package is different shape, different, box size, located in a different part of the facility. And so it's really difficult to automate that level of variability that exists in that process. And so you're really relying on people entering data, for example, counting inventory and entering data into a system so that Amazon can keep track of what's left over, what they have, what they don't have. And anytime you're relying on manual data entry or data that is identified by people as being relevant, that's when you get into a little bit of trouble, because not only do you have the risk of timeliness, so they may not provide event level data exactly when things happen. If somebody's counting inventory, for example, that might be an end of day job that they do. But also accuracy and quality is also at a risk, because anytime people are involved in any sort of data creation, that is always a risk for accuracy and always a risk for people making mistakes and things like that. So data that is created manually by people is very useful at a high level to make decisions, but we're not at a place yet where such data can be reliable in terms of making timely decisions in the same way that we can make when we have automatically created data. So some of the challenges with manual data collection and why these challenges exist. So I spoke a little bit about the complexity of some businesses. So again, for example, Amazon, anytime you're dealing with a pick and pack operation, we don't necessarily have, in an ideal world, we've got robots walking around and picking things, but that technology is very expensive, very difficult to scale, and also in some cases not fast enough. And if you're dealing with food, for example, robots, they can't operate in cold temperatures. And so if you, let's say, are dealing with frozen meat or something like that, it's going to be really difficult to implement robotic arms everywhere, because they need to stay warm or they need to run all the time. So again, quite costly and perhaps not as scalable yet as we'd like to think. And so companies that have tried to address this, there's a few different challenges, at least from my perspective, on why manual data collection is difficult. But it first starts with technology. So I think we're still in a stage where technology and data have not quite reached that intersection where they work very well together. At the end, really where we're evolving to now, and we've seen kind of the growth of machine learning operations and operationalizing machine learning models and building web applications around machine learning and algorithms and things like that. And that's really where we're headed. We need to get to a place when we're building technology includes algorithms, it includes data collection mechanisms and monitoring practices, it includes outputs that are vetted. And a lot of companies that build their own technology, so I think some of the older views of technology, it's around kind of like technology that creates data or enables the capture of data, and then technology that transforms data. And the technology that transforms data is really your algorithms, your things that rely on good data. And so I think a lot of companies still aren't operating at that place where we have a really good intersection of the data continuum. So all the way from collection to ensuring that data is good so that it can later be used. And a big reason for that is because in the past, we just didn't use data in that way. So in a lot of, again, manufacturing or, thinking of a grocery store, if you think about a grocery store, what does a grocery store care about? Inventory, making sure that they have enough of a given product to serve the customers or to meet demand. They're interested in demand forecasting. So just understanding things like totals, how many bread items did we sell? How many yogurts did we sell? So that we can make sure that we have enough in stock. But now that we're reaching the stage of personalization and customization, and we're really trying to get to that place where not only do we have really good demand forecasting, but we can improve our demand forecasting by understanding the people who shop at our store. We can improve our inventory management by understanding why people buy what they buy. We can improve our supplier management and all of these different opportunities. All of that relies on having good data, which we don't have right now in many of these industries. And again, the reason being that we don't have that intersection between technology and data management practices. The second big challenge with manual data collection, and this is pretty common in legacy companies, and I've seen this again in especially big organizations, and prior to HelloFresh, I worked at a few big organizations, but companies that have really disparate technology, so they build technology to solve a very particular problem. They may have tech that exists in just different departments, and decisions around tech are made very quickly and with agility in mind. But what happens is then you've got a whole bunch of different technologies that live all over, and information is quite distributed. And we've heard about things like federated learning, for example, or we've heard about even some companies. There's some really cool companies that exist out there that try to consolidate data from different systems. And of course, there's a bunch of privacy implications and security implications. So that's always a challenge when data lives disparately. But right now, a lot of companies don't really have a way of consolidating data in one place, and not only consolidating data, but consolidating relevant data. So going through that process of designing, for example, schemas and data warehouse schemas, and sort of finding the optimal technology that's going to let us make data meaningful and put it all in a place in a timely manner that's going to be meaningful. So that's a second really big challenge. The third challenge I often see is the poor metrics or data element definitions. So when it comes to the question of what data should we be collecting and how often should we be collecting it, again, this is often a gap on why we can't use data for analytics with non-automated collection, is because we don't necessarily think through or have a good idea of what is the metric that we actually want to collect. So again, in the example of inventory, at the end of each day, does it make sense to collect inventory at the end of each day? Does it make sense to collect it at the end of the week? Again, because we're often counting. So inventory counts, for example, in many companies are validated by hand. You have somebody walking around counting inventory and then updating those numbers in systems. Or if you have, let's say, a product that isn't, like grocery is one example where produce, for example, you can't put a barcode on every single thing. But then in other places like Amazon, you can put a barcode on every single thing. So that's a little bit more automated, and you only need to do inventory counts once a year, let's say. So it's a little bit better there. But in terms of metrics and how often we should be collecting that data, what that metric looks like, is there other things that we should be collecting to enable kind of long-term optimization? I think the reason this isn't great at a lot of companies is because we don't really have visions on what we can use. We don't really have a plan for how we can use this data in a lot of these environments. A really good example is around supplier optimization. So a company that perhaps has many different suppliers that supply the same type of product. So if you think about a traditional grocery store, the potatoes that are sold probably come from 5 or 10 different suppliers, and a grocery store that maybe has many locations, there's going to be even more suppliers than that, and different suppliers will operate or be optimal at different times of the year. And right now, these decisions around purchasing are largely made by a person who perhaps knows that category really well, perhaps knows the suppliers really well, and then builds those relationships to kind of decide on what should we buy from whom and when. But could we automate that? So if we had a bit more data, if we had more data around the supplier performance, lead times, supplier like quality of product, and again, that would all have to be manually collected because we don't necessarily have the technology to monitor things like quality automatically and well. So unless you're doing, again, some sort of automatic sorting in a facility, some companies may not have that technology in place. And so from there, kind of making the decisions of what should we be collecting, and not only what should we be collecting, but how can we use that in the future is sort of a challenge that we have. A really good example is it was an automotive company. I can't remember who it was. It may have been Lincoln, maybe. I can't remember, but one of the big auto guys, they were one of the first actually to implement a graph algorithm for their supplier management. And this is exactly what they did, is they sort of monitored where they would need to get what from and the price fluctuations in a given year. And so from there, they were able to essentially make automated decisions to say, if we're running low on X item, you should order it from this particular supplier at this rate. And, then we always make sure we have what we need. And so in theory, these things are quite cool and they're quite interesting to automate. But again, having the data gaps is a big challenge in that. And the last two challenges are one, lack of process or product analysis ability without reliable data. So if we don't have good processes to collecting data, I think at the end of the day, that's the other intersection that is often a gap, is the intersection between process design and technology and data integration. I think a lot of folks, especially when it comes to, again, physical processes, we tend to think of process as that Lean Six Sigma perspective, that very kind of process improvement, process design, lean process design perspective. But we don't often sort of integrate the two together. And often technology reviews are done as a separate work stream than process reviews. And so we don't think about what are the points in the process that we do want data so that we can make better decisions. And so finally, what this leads to is an ability to making effective decisions on time. So when we do make business decisions, again, with something like a digital social media platform, when you're collecting event level data every second, you can really optimize advertisements. You can sell advertising space, and you can do that on a nanosecond basis. But you can't do that with other parts of the business that have a physical product. Again, another application that I can think of just as we're talking about this is inventory management. So being able to predict that you're going to be low on inventory. If, let's say, you're working with perishable food items, being able to predict that inventory is going to run low or inventory is going to go bad, depending on when it arrived, where it came from, and then saying, okay, you should order something to replace this inventory that's about to go bad, or you are at risk of experiencing waste in this particular area. And so I think having that level of detail would be super valuable. Okay. So in terms of data collection options, I think, again, kind of speaking broadly, there are ways certainly to optimize. There's certainly technology that exists out there. So readers like NFC tags, RFID tags, and readers, I think, are super valuable. I don't know, a lot of companies that have big warehouse operations will have some version of this. Some challenges that exist with this method are around maybe Wi-Fi in some cases when you have a really big facility. Again, if you're dealing with a cold chain, sometimes those technologies don't work. And so having temperature proof, and that's kind of another element that you may not consider if you're not working in that type of field, but tracking capability, and then of course the investment. The second option is around automatic data quality checks. So anytime you are relying on building or on people supplying data or people entering data into a system, really building those automated data quality checks are critical. And again, if we define metrics that we know are reasonable, or if we're able to define what we're going to use the data for and how we're going to use it, then building automated checks should be fairly straightforward. And then the third thing that I'm going to focus more attention on is building a culture of experimentation for one-time data collection. And so this is really about trends that happen, sort of studying things and how they work so that we can make better decisions. So experimentation, I think experimentation is super valuable. A lot of times companies will kind of refuse to go into something, or they'll refuse to do something because there's a big time investment and resource investment into doing an experiment to collect some data, or perhaps altering a process for a period of time so that you can collect data and see if there's value in it. And so experimentation is really where it should be happening, is where we don't know if a benefit exists, or if a benefit doesn't exist. It works both ways. One thing I'm a big proponent of, and something that we do at my work with my team, we really try to build this experimentation culture where we dedicate at least some time on a weekly basis to explore a project where we don't actually know if there's going to be a tangible benefit, but it's worth exploring. And if something works out, excellent. And if it doesn't work out, then it is what it is. I do think, though, experimentation is critical in innovation, especially when trying to find new ways to optimize your operations, to kind of do research on something, or to sort of make better business decisions. And so I can give a quick example of something that we're working on as a team right now. And this is not even just HelloFresh specific, but this is sort of a broad problem that exists in the world. So packaging, now that we're moving kind of into this culture of e-commerce, and more people, obviously COVID had a big boost, gave a big boost to this e-commerce industry. But in this industry of e-commerce, we're very, very dependent on packaging. And packaging is one of these areas that isn't quite well thought out, in the sense of we've solved for packaging in the past. So for example, healthcare packaging, or organs, like we're shipping organs around the world, we've solved for keeping things cold. We've solved for it with materials like styrofoam, for example, and things like that. But now we also face this pressure of environmental friendliness. And so we're kind of at this interesting intersection of the world, where we have a problem that we need to solve, in this case, packaging for any industry that ships products. We have a problem that we need to solve, but it also is veiled with kind of the social responsibility of not creating more waste than what exists today. Because in reality, let's say you get a box delivered from HelloFresh, you could go to the grocery store and buy ingredients, and you're probably going to use a little bit less packaging than what you would if you were to get a box from HelloFresh. However, HelloFresh solves a different type of problem, which is around food waste. So HelloFresh, we're socially responsible, and one of our big objectives is to solve this problem of food waste, where we're shipping something, where we are giving you just what you need, and so you're not going to create a different type of waste, which typically results from grocery shopping. So it's kind of a give and take. But on the flip side, again, now there's this packaging question around how do we make sure we're using good packaging, the compostable packaging, environmentally friendly packaging. And we're not the only company dealing with this challenge. Amazon has the benefit of not really dealing with perishable food items outside of their grocery stores in the US, but they don't ship any perishable food items. And so for them, it's a little bit easier to not have to worry about insulation in a particular way because they can just kind of ship things as they are. That said, if you've got a box from Amazon, every once in a while, you'll notice that you'll buy maybe a small, tiny item and it comes in a very giant box. And so again, that's a form of waste because it's really difficult to predict what packaging needs you're going to have. It's really, and again, when you're dealing with that level of variability where you have so many different products that are different sizes, that small, large, it's really difficult to predict what packaging you need to have in place to do that. So I think packaging is super interesting for me because I think it's an area that definitely can benefit from experimentation. And this is both around, so some examples around, let's say, packaging sizes. So if I'm on Amazon, what size boxes should I have to minimize the waste or to minimize the available space that goes into a particular package? And this is an interesting question because by minimizing the amount of space that's left over in a box, it doesn't only help the customer by producing less waste, but it also actually helps the company because you're paying less for shipment. You can fit more boxes on a truck, for example, if you have the right sizes. So Amazon's done a great job, for example, of optimizing products that are bundled together. And so if you ever buy things online, you might see, I'm buying this, and Amazon may recommend that you buy something else or people also bought. So you can do that pretty easily. But there's also that next question then of now, how can we predict what people are going to buy so that we can order the right amount of boxes? So on the data collection side and the experimentation side, there's something to be said around how do we experiment with different combinations of boxes so that we can see what that answer is. And so it's not really kind of a linear answer. It's more of a roundabout answer. I guess it's a little bit of a loop. The second thing that's an interesting question around box sizes is around, could you collect volumetric data, for example, on different items that exist in a facility? So could you build a model which then says, okay, a customer bought these 3 items, here's the total combined volume and the shape of these items. And volumetric data is really difficult to collect because some items will have, again, different shapes, awkward shapes, especially dealing with food. Food is a little bit different, but different items will have different shapes. Some might be soft, some might be hard. And, then you also need to have a box that has the right stability to be able to hold a certain amount of weight. And so all of that comes from manual data collection, because when we order products, for example, some suppliers may give product dimensions, but if you're dealing with a product that, again, has some variability in the product itself, you may not be able to get those dimensions. And so you need a process to be able to collect all that data on a consistent basis, which is a big investment up front, which then could enable you perhaps to define some optimal box sizes to have an inventory so that you can minimize the amount of waste that you're creating. So that's one kind of thought, and something that we think about as well in HelloFresh. Another really interesting experiment that we've done recently.
Ask something.
Yeah.
Sorry
Oh,
for
yeah, of course.
I was trying to wait a bit till you take a pause. Yeah, I'm just trying to wrap my head around this experiment. So experiment in the sense that it's like I don't know, an A/B test kind of experiment, or
Yeah.
okay, yeah,
Yeah.
because I'm trying to
Mhm.
imagine like let's say we talk about packaging, and let's say we talk about HelloFresh, right? So you have some, I don't know, groceries, right? That
Yeah.
people order. And then experiment could be we have only one box of certain size
Mhm.
versus we have, let's say, 3 boxes of different
Mhm.
sizes, right?
Mhm.
And then what you want to do, the metric you want to optimize is the room left in the box, right? So you want to make like you want to, yeah, basically have no room left there.
Yeah.
And the people who actually package this, or I don't know how you package this, so they would need to somehow measure the spice
Mhm.
left in the box, right? And that
Mhm.
would be the experiment, right? Am I correct?
Yeah, that, and also there's other things we need to think about because, for example, with a product like HelloFresh, we're trying to create a customer experience where when you get your box, the box is nice. It's not squished. Everything's not kind of like jumbled together because then the product would be ruined. So from an experiment perspective, We need to, so this is an example where we would, number one, need to collect a bunch of data, then try to define an optimal box size. But the thing that we would test for is not only the amount of volume that's left. And because grocery products do have some variability in the sizing, inevitably there's going to be differences in the amount of volume left over. So the second thing we would also test for is like customer satisfaction in reaction to that particular product to see if perhaps the box size influences customer opinion. So right now, for example, we think it does. We think people expect, they get a box, it's nice, nothing squished, everything looks nice and organized. And so we need to have a box that allows for that. But do they care about that? I don't know. Do they care about just getting their product, and maybe the box doesn't matter? Maybe this is something we think people care about, but they don't actually care about. So maybe there is an opportunity to optimize further. So that's kind of the experiments that we do, and that's one
That's
experiment that
interesting.
I think would be good for like an A/B
Hmm.
A/B test.
Yeah. Yeah, that now that you mentioned, like, I don't know, imagine potatoes, like
Yeah,
you're going to peel it and cut it, like how important it is that it looks nice, right?
yeah,
Maybe
it's
it's
true.
something. And you just ask, like, every week you send something on there, hey, what do you think about the package you received? Like, did you like how it looks? Or and then the answer would be, yeah, I did. I did not, and I don't care. Something like that.
Yeah, exactly. So in some cases, we do ask. So sometimes, if we have product design sessions, we may do like a focus group and get concrete feedback from people. But that's another tricky part because when you're doing something like this, and so experimenting is really hard in this type of culture where, or in this type of product where we can't monitor people's actions. Like Netflix, for example, this is a famous example, but Netflix used to collect feedback on a star rating, and then they changed it and they only started collecting thumbs up or thumbs down. And the reason they did that is because they saw that behavior was actually much more indicative of people's satisfaction rather than the opinion coming from people themselves. And while you may rate Saving Private Ryan as an excellent movie, you're not watching it every weekend. You're going to watch Encanto every weekend because it's nice and easy and light, right? And so you're much more likely to watch that movie than something that's a very heavy, dark movie. And so I think for us, that's kind of the other part of experimentation where we're trying to figure out like what is the right metric. And so when we talk about metrics, how do we measure the success of our experiment, and how do we compare one group versus another? And when we do these experiments, when we make changes to our product, for example, do we do a before and after test, or do we do two separate customer groups test? And the reason even that's an interesting question is because people may be very different. And perhaps the people who ordered a box that given week, maybe it was spring break for children. And so everybody ordered boxes. And so that's a very particular type of demographic in a particular time where people perhaps have more time to cook there. And there's many factors that go into somebody's decision there. And so getting feedback is helpful, but is not always representative of what happens. And so for us, as we're sort of doing these experiments, we also have to think about, and it's a big part of what my team will contribute to as well, is kind of thinking about what is the methodology that we use to calculate the before and after. What's the methodology we use to assess whether something worked or doesn't work, or whether people care or don't care. And then on that note, the other kind of big thing that's really valuable is we do collect feedback through our app on a weekly basis for our recipes. We also collect feedback through occasionally on the kind of overall experience. And so, for example, natural language processing, that's a really big application for us, because being able to read through comments really quickly and identify, what portion of people, so if we have X amount of people that respond to our surveys on a given basis, what portion of these people actually care about a given attribute of the product. And ecological sentiment, for example, we know people care broadly, people care about the environment, but how much do they care, and what's kind of that sensitivity of where they care more about their food being fresh versus, or their food being cold versus the amount of ice that we use, for example. And so it's kind of like, it's a very interesting thing to think through, and sort of like a sensitivity type of analysis. So instead of even looking at particular A/B tests, we almost want to collect data about the sensitivity of people towards a certain topic, and then we can make better decisions based on that.
So an experiment could be in this case. So this group of people gets more ice, and this
Mhm.
group of people gets the same amount of ice as usual. And then you
Yeah.
look at the sentiment of the feedback they write.
Yeah, exactly. Or even we could do like take one group of people and send them a regular amount of ice one week and the next week send them more to see if they notice. Like, is this
Mhm.
something that they would actually pick up on and notice or comment on perhaps? Um, yeah, so it's really
And
quite
that's
interesting.
before and after, right? So the same people you change. Okay, interesting.
Yeah. Yeah, so it's quite interesting. And so the second kind of example that I wanted to talk through was so another example that we're thinking about is obviously we're a food company. We put ice in our boxes when we send to people. But there's always a question. And I think this is a really interesting project that we worked on here in Canada, because I think when it comes to kind of also logistics and sending materials broadly, we often don't compare Canada and the US to Europe. And so in Europe, countries are much smaller than they are here in Canada. And so anytime we have a client in Europe, let's say a HelloFresh customer in Spain, their box is really not going to travel very far. It's going to go maybe 10 hours maximum is maybe the farthest that the box will travel. But in Canada, we're a very, very big country. And so here the boxes are traveling very far. And same with the US. We have the distribution facilities throughout the country. And so our boxes will travel very far. Um, and so a common problem that always comes up is exactly around the amount of ice that we should be putting in the box. And so so one of the things my team did with an experiment was trying to see if ice melts in a very predictable way. And so that's another really kind of basically challenging physics problem, because as ice changes its state, so moving from a solid to a liquid, it absorbs heat in different ways. So solid ice will absorb heat kind of evenly, I guess, but liquid ice or liquid ice or water, I guess, won't absorb heat in that same way. So water and liquids in general, their heat absorption is quite messy, and you can't really control how heat is absorbed. And so in some cases, it may heat up faster or heat up slower, depending on where the ice is positioned in the box, what's around it, is it surrounded by other things. And so this was a really interesting experiment where this was a true experiment where we thought about, could we see how ice melts? Is there a pattern to how ice melts? And what is it influenced by? So we know that melt rates are influenced by other mass being in a box. So if we put, let's say, a package of ice in a box and we put meal kits in it, the ice is going to melt a little bit slower because ideally other masses will absorb heat faster. But depending on the type of mass, if it's protein versus a vegetable, it's going to absorb heat in a different way. So a potato will absorb more heat than cilantro, for example, or a herb or parsley or something like that. And so this was a really interesting experiment, because how much ice to put in the box has never historically been a problem for really grocery delivery, because before kind of HelloFresh became a big thing and meal kit companies became a big thing, even Instacart here in North America, groceries weren't really delivered. And a lot of the grocery stores that deliver groceries, they deliver groceries within a radius that's quite close. And so it's not really a problem. And when we initially started this experiment of trying to collect a bunch of data on ice, we were trying to find studies on the topic. We were trying to see if anybody had looked into this problem before, and nobody really had. We found maybe one or two papers from the 90s and early 2000s where somebody had asked themselves, in light of e-commerce kind of booming and anticipating that this will be a problem eventually, but not a lot of work has really been done in this space. And so this was a true experiment that we kind of started working towards, where we did a bunch of tests. We just put ice in boxes and ran a bunch of tests and collected a bunch of data on how ice melts and sort of the
The
pattern that it
box
follows.
stayed in the office, or did you actually send it?
We actually have a facility nearby that does packaging
Uh-huh.
testing, and so we did it. It was a proper experiment, proper experiment that we did in a testing place.
Okay, so it's like a laboratory, right?
Yeah.
Where you would put some sensors inside the box and monitor how the ice melts.
Yeah, exactly. And the challenge with that is that, the temperature in a box is influenced by anything. And the only really true way that you can look at the state of ice is by visibly looking at it. So if you don't have a camera in the box, for example, which is also kind of hard because you need a camera that can last upwards of 50 hours in some cases, there's really no way without opening the box to check the state of ice. And the moment that it starts turning from 0 degrees ice to 0 degrees water, for example.
And you cannot really take a peek and then close it, and
No.
it's like Schrodinger's ice, right?
Yeah, exactly. That would ruin the integrity of the experiment. But yeah, and so it's really interesting. And so we kind of, it was an interesting project. The reason is because so heat transfer is very complicated. And I think anybody that, and I'm not a physicist, but anybody who has dealt with physics in general is complicated, but anybody who's dealt with heat transfer and again, many applications, right? Like in, chemical engineering and even civil engineering, when you think about, things expanding and shrinking based on heat and how heat gets absorbed and how heat escapes a given mass. It's quite complicated, and in a product which is quite variable, so where you have different sizes of things, different recipes in a given week, meat, no meat, different combinations of products, different sizes of boxes, this becomes a quite challenging question to answer. But what I encouraged my team to do, and kind of what we decided to do, is we decided to focus on trying to conduct a baseline experiment. So just trying to see, how does ice melt in an empty box? And assuming that anything else we add to the box will only slow down that melt rate. And so in reality, we're really just concerned about, we just want to see what the pattern is. And so if we can find kind of a consistent pattern, and so ice melts kind of like this, where it goes from negative temperatures frozen very quickly to 0 degrees frozen. And then it's kind of flat lines until it reaches 0 degrees liquid. And then it kind of speeds up again. So as soon as it's liquid, it starts warming up quite a bit faster again. And so we decided to build an experiment where we built and we haven't put this into production or anything yet, but we're trying to define essentially a mathematical model that can represent ice melting as a function of time and as a function of weight of ice, so how much ice is in a box, and to see how fast it'll melt based on different temperatures in the country. And so this has been a really interesting data project because we also had to collect temperature data from a bunch of different locations and try to produce temperature curves that a box might experience and try to account for how much faster or slower ice will melt. And again, it's challenging because it's as it reaches different temperatures throughout the day, the mix of solid and water ice is different. And so that melt rate is going to be impacted a little bit differently. But it was really fun. And I think, so the main message that I kind of want to share with this is that, in some cases, people know this is a really complicated problem. And so there's always going to be some organizational questioning or pushback on, is this worth it, right? Like if we have X amount of resources, is this the best place to put them? But we did actually find that, ice does melt kind of predictably. And if we sort of simplify the problem, like we don't have to do a full-fledged experiment where we're taking every possible sort of variability of a box. We could probably produce something that's quite a baseline model that's still going to add business value. And this is a cool project because we didn't know that at the beginning. And, I'm very lucky that the team I work with, everybody was quite encouraging for us to say, yeah, like, let's see if it goes anywhere. Like, let's just run the experiment and see if it goes anywhere. And that's one of the things I love about HelloFresh is that we're very big on trying to answer these complicated questions, because a lot of these problems that exist have just no one solved them because they've never existed before. And so now we kind of get to be the first to frame them, to solve them, to build something that can essentially help many other industries as well. So that was kind of a cool example. And then I think on the flip side, it's the other challenge that there's no solution to it yet in general, not just with HelloFresh, but it's around the opposite problem, which is how to keep boxes warm in the winter. And I know there's tons of like pharmaceutical applications of this as well, where they also haven't solved the problem of how to keep cold out in a box that's traveling. So we'll see. Maybe that's the next experiment.
Yeah, and the interesting thing here, when I hear experiments in context of, data science, data analytics, I usually think about A/B tests or before-after tests, like you said, but not actually tests, experiments in a lab. And
Yes.
this is pretty cool. This is different
Yeah.
level of experimentation. So you put something in the box and then you observe it for, I don't know, 1 week, and then you uh, build models on top of that. That's really cool, like proper experiments.
Yeah, and I honestly think it's a really it's a core function of data teams. I mean, again, going back to kind of data collection and in traditional statistics, that is what statisticians would do. They'd go out, they'd collect a bunch of data, and then they would do analysis. And I feel like as because we largely live in this world where data is digitally created and it's automatically created, we've kind of forgotten that practice. But it's a thing. We can still do that, and we can still learn a lot about the world around us if we if we take the time to do that. So I'm a big proponent of experimentation.
Yeah, that's cool.
Yeah. So a couple more slides here. So in terms of, again, just kind of the process we typically follow. So with this, again, ICE example, really it's just about establishing an objective. And it's important to highlight that with experiments, sometimes there will be a answer, sometimes there won't be an answer, and that's okay. And everybody needs to be okay with that this may result in something and it may result in nothing, and that's okay. Develop some sort of hypothesis. So it's very traditional statistical analysis process. Define some sort of framework and plan and how we're going to measure success. What I generally also suggest is execute once on a small scale just to validate your approach. So sometimes one thing I will notice that with labs, and if you are engaging a lab in testing, obviously that costs a bunch of money. So you don't want to build a huge experiment only to find out that you've done it the wrong way or you haven't considered a particular factor. So execute once on a small scale, validate your approach, refine it, and now execute and validate. And then once you have sort of a concrete plan, then launch the experiment. And with something like ICE, for example, we probably did quite a few months of testing and, just kind of refining our approach, refining what we were going to test, the different scenarios that we wanted to test that would give us sort of a full picture. So yeah, starting small and then kind of building on it as you go. But it's quite achievable. And I think it's quite a good application of data. And so some use cases for experimentation. So again, you can do things where you have existing data, like shipping box sizes, and this is the one I spoke about earlier. Any sort of optimization problem. So I think operations research is an area that's becoming quite popular again in light of a lot of these personalized manufacturing environments, and again, environments like Amazon, like HelloFresh, like anywhere where there is a personalized, customized offering. We're seeing quite a bit of a focus on operations research, and really these problems that could be optimized. And so I think experimentation has a lot to do with that as well, especially where data may not exist. So some other examples in procurement, supply chain. So again, data collection to see if you can optimize which buyers you buy from. So the automotive example I shared earlier. Inventory versus product allocation. So optimizing how much you hold in inventory versus how much you order on a just-in-time basis, for example. And this is really big in any sort of perishable item. So all grocery stores, any food production company, everybody's trying to reduce food waste because that's a really, really big problem as well globally. And so anytime you can kind of predict and minimize food waste is an excellent optimization opportunity, and of course, prime for experimentation. Another like cool application is around aging of product, right? So there's a lot of really interesting innovations, but when it comes to produce, for example, if you place different types of fruits together, they emit different gases, and so they may make each other age faster. So for example, if you put like a banana next to an orange or something like that, the orange may make the banana go right faster. And so there's a big sort of problem around how do we put things in the right locations. If we are a food facility, how do we organize things so that we can emit the right gas to promote less aging, and we can put things in a way that they're not going to make each other go like age faster. So that's a big experimentation opportunity. And lots of cool companies, like one thing I've seen recently is those little stickers that exist on the citrus fruits. You can put those on and they're stickers that emit the right type of gas for citrus fruits to age a little bit slower. So there's tons of experimentation in this space. And then again, in manufacturing, so any sort of like cold chain design. So when you're dealing with ice, temperature fluctuations and things like that, or also production line and error identification. So I think these are all interesting use cases. And I think that's largely all I have. Yeah. I guess I'll open it up if there's any other questions or anything else you want to chat about.
What is DI? Is this your initials?
Yes.
Okay, I suspected that. I was
This is
thinking,
me.
what? Okay. Can you remind us what was the name of the company? I think you mentioned that this automotive company that experimented with this supplier buy-in optimization.
Yes. Let me just look it up super quickly. I think it is. Let me look it up super quickly so I don't get it wrong. Let me quickly look. Um, I thought it was oh, I'm gonna get the name wrong. I thought it was Lincoln. I don't think it's Lincoln. It's one of the other big um, companies. So
If you come across this
yeah, I'll come
article
across it and I'll let you know.
or yeah,
Yeah.
do you have some, I don't know, maybe blogs or talks about some of these experiments that you do at HelloFresh? If, let's say somebody wants to know more in more
Mhm.
details how you approach some of the things, like for example, we talked about using NLP for sentiment analysis and things like this. Perhaps you have some talks that you can also share with us for those who want to
Yeah, we
understand.
haven't done too many. So as HelloFresh, we have a Medium page where we post a lot about some of our engineering projects that'll be based on some of these. So I can link that out. And then aside from that, like I'm happy to connect. So if anybody's curious about some of the things we're doing, then I'm happy to connect. And I'm sure we'll be doing some more of these. But I know we've done quite a few, especially around sustainability. We do quite a few talks in Germany. So some of the various supply chain conferences. We've talked about our dynamic packaging configurator, which is one of the things that which is basically trying to do this, collecting volumetric data at an ingredient level to predict box sizes. So I believe that was shared probably a few months ago at one of the supply chain conferences in Germany. But I'll send you a link to our Medium page as well, and that will have a whole bunch of different stuff as well on um, how we build models and just the different methods we use for customer analytics and other supply chain analytics as
Yeah,
well.
thanks. Yeah, it's so for me, I work at a digital company, more or less.
Mhm.
Yeah, we do have some non-digital things like we are a marketplace and we sometimes send things, so we have like deliveries. Anyways, yeah, this is such an interesting talk to also look at other companies that live in non-digital world, what kind of problems they have. For example, this ice, it never occurred to me that this is actually a thing. This actually can be a problem. To me, I just get a pack, I see there is some ice, I think, okay, cool. Then my kid loves getting some ice because he likes playing with ice. But it just never occurred to me that this is such an interesting problem.
Yeah, yeah,
So
yeah.
yeah.
Also, the company is Jaguar. It's Jaguar is the automotive company, and I believe they cut their supply planning time from 3 weeks to 45 minutes using graph databases. So it's really like
That's pretty cool.
innovative application of graphs.
Do you do anything similar to that at HelloFresh?
So we do have one of the ways we use graphs is our recommendation engine. So when we recommend recipes, but we don't have anything right now for supplier optimization, and it's something that I'm thinking about. So I think from a data perspective, like similar to this ice thing, that's another really like interesting area for me to think about because again a lot of our buying decisions are made by people who are buying, and they know the product really well, they know the category really well, they know the suppliers really well. But again, is there an opportunity to optimize? And again, in Canada, this is an interesting problem because let's say lemons, for example, in sometimes in the year we can get them from the US, so we may get them from Texas, but in colder months we have to get them from Mexico or somewhere further south, and those distances provide a prime opportunity for optimization. Where in Europe, if you're located in Spain, for example, you probably don't have to worry about that complexity. But if you're located in Norway, you're going to have some of the same problems. And I think that's often, again, for physical supply chain processes, that's often like a missed consideration when we think about where a country operates and where should we be optimizing versus not.
So basically, every country, every market where you are in uh, has to have a team of
Yeah.
how is it called, like procurement team, or I don't know what's the right
Yeah.
name for that. So they have to take care of that, and it's mostly manual work, right? So they or
Yeah.
maybe not manual, but they have to rely a lot on, making physical contacts, calling people,
Exactly.
knowing who to call when, right? So a lot of domain
Yeah.
knowledge.
Exactly. And then that's another kind of interesting question around, the level of automation, like what is the appropriate level of automation? And I know this is a hot topic, I think, in general in manufacturing of what is the right amount, because if so much of business happens with people personally connecting and having those very personal relationships, let's say between suppliers and buyers. And, can you automate that, or is that something that should be automated? Does it actually yield to optimization, or would that then change the structure of how suppliers price products? And maybe it all just becomes kind of maybe it becomes more expensive over time. Who knows? But yeah, it's a very interesting problem.
Once you solve it, will be quite interesting to invite you to take a look.
I will let you know if it ever happens.
Okay, I don't see any more questions. Maybe last one from me. If somebody wants to ask you questions after watching this and recording, what's the best way of reaching out to you? Is it LinkedIn?
LinkedIn. Yeah,
LinkedIn?
add me on LinkedIn or message me on LinkedIn, and I'll be sure to respond.
So we will add your LinkedIn to the description, and then if there are any links you want to send us, please do. We'll also put them in the description. And thanks a lot for joining us today, for sharing all this knowledge with us, for telling these stories. This ice story was especially interesting one.
I'm so glad.
Yeah. And thanks everyone for joining us today, also for watching, for asking questions. And yeah, I think that's all from us today. So
Awesome. Thank you so much for having me. This was super fun.
yes.
It was great to
Have
meet
a
you.
great